here's the problem as posed, and here's a picture of the situation. Here's the graph of y equals negative x squared plus 4, where I solved the original x squared plus y equals 4 for y, and also the line y equals negative x plus 2. You can find the points of intersection by using the substitution method. So the graphs intersect at negative 1, 3, and 2, 0. And what you have to visualize is that a typical cross-section has this segment as a diameter. You visualize this entire graph lying on the floor, and then the semicircle kind of comes up out of the floor. We have to find a formula for the area of that semicircle based on the value of x, which creates a typical cross-section at that point x. The coordinates of this point right here are x, negative x squared plus 4, and the coordinates of this point are x, comma, minus x plus 2. So the length of this diameter is this y coordinate, take away this y coordinate, which I've shown right here. And that simplifies to the opposite of x squared plus x plus 2. So the radius of that semicircle is half of d, or there's the 1/2 put out front. So the area of a circle with that radius is pi times the radius squared, which is this 1/2 squared times this trinomial squared. So 1/2 squared is 1/4. There's the trinomial squared. And so the area of the semicircle is 1/2 of the area of the circle. And that's why we have this pi over 8, because I took half of the pi over 4. So there's a formula for the area of a typical semicircular cross-section right there. And we want to integrate from negative 1 over to 2 along the x-axis. We've got all these cross-sections coming here. So there's the formula. Manually, if you're going to evaluate this, it's pretty tedious. We've got to square this trinomial, then take the antiderivative of that term by term, and then evaluate from negative 1 to 2. And you have to be very careful when you evaluate it. And I'm not going to do that here, but I believe the answer is 81 pi over 80, and here's sort of proof of that. I've defined f of x and g of x as the parabola and the straight line, points of intersection. Here's setting up the integral, where I have the pi over 8 out front, and f of x minus g of x, the quantity squared, gives me 3.18, and 81 pi over 80 gives me the same exact answer. So that's probably it. So good luck on evaluating that definite integral that represents the volume of the solid generated by slicing.